So now that we have reviewed graphing a line, we are going to be talking about how to solve a system of linear equations. So linear just means line. You can see the word line inside of the word linear. So it just means there are more than one lines. That is what a system is. There's just more than one. So a solution to the system is going to be where the two lines meet, so where they intersect. So the point of intersection is going to be your solution. The reason behind that is that every single point on a line, so if I were to draw a line, every single point on it, so here, are all x and y pairs that actually make the equation true. So if I add a second line and I look at all of its points that are always on its line, and those are true for its line, I just need to go and find the intersection, and the intersection is where there is an x and y pair that is true for both of the equations. And that is what we're looking for. We are looking for that intersection. So that is going to be the solution for the system of linear equations. So we're going to start off by solving these graphically. So we're going to graph lines and we're going to see where they intersect. So sometimes it's difficult to see where they intersect exactly, so because it's really hard to draw straight lines. So because of that, you're going to try to find what looks to be correct, and then you can plug in that x and y value into both equations to see if it is a true statement. So let's take a look at some examples. So on the first one, we have two equations. So here's the first equation, and here's the second equation. So I'm going to draw the first one in blue, and I'm going to draw the second one in green. So if you notice, the first one does have a slope and it does have a y-intercept. If you remember, anything times 1 is itself, so there's a 1 in front of this x, and anything plus 0 is itself, so there's a plus 0 out here. So that's telling me that my y-intercept is here at 0. And my slope is going to be 1 over 1. So both are positive, so that means I'm going to go up 1, right 1. So again, we had an intercept at 0. It's telling me to go up 1, right 1, next one, up 1, right 1, so forth and so on. Or I can treat these as a negative 1 over a negative 1, so I'm switching the signs of both of them. So this is telling me to go down and left. So down 1, left 1, down 1, left 1. And I can continue that pattern, and I'm going to draw my line. And as you can see, it's already sloppy, but that's okay. So now we can move on to the next one. So we have a y-intercept of negative 3, so I'm going to come down to negative 3 and draw my y-intercept. We have a slope of negative 2 over 1, so negative 2 over 1 tells me to go down 2, right 1, because 1 is positive. So I'm going to go down 2 and right 1. So you can see that the direction that these dots are going are in the opposite direction of the line I just drew. So I'm going to go and I'm going to flip the signs of each of these, and I'm going to make it a positive 2 over a negative 1. So it's still negative 2 divided by 1 is the same as 2 divided by negative 1. I get out a negative 2. This one's telling me to go up 2 and left 1. So from my y-intercept, I'm going to go up 2 and left 1. And notice that I actually hit one of the other points I drew. That's a great sign. So now I'm going to go and I'm going to sketch this line. And you can see now that I have an intersection. And that intersection, that XY point, my X was -1 and my Y was -1. So if you remember, each of these little hashes are going to be 1. So this is 1, 2, 3. Going down would be -1, -2, -3, so forth and so on. To the right are positive numbers, and to the left are negative numbers, so -1, -2. And the first number is always your X, the second number in the pair is always your Y. So your X-axis is your horizontal, your Y-axis is your vertical. So from the center I went left 1 and down 1 to get to this intersection. So here's me moving left 1 and here's me moving down 1 to get to that point. So -1, -1 is that point. So we can do a quick check and see if that is the solution or not. So I'm going to go and plug in the -1 for X and the -1 for Y into both equations and see if it comes out to be true. So the first equation, we have Y equals X. So if I plug in -1 for Y and -1 for X, I get -1 equals -1, and that's a true statement. So then I can try it for the second one. So our second equation was Y equals -2 X minus 3, so this is going to be -1 for Y, and my X is -1. I'm going to put in parentheses when I'm doing that substitution right there, because this -2 is being multiplied to the X, so this -2 needs to get multiplied to this -1 that I just substituted in. So we can start to simplify. -2 times -1 gives me a +2. And then 2 minus 3 gives me -1, and that's what it was on the left side. So again, that worked out. So that is the solution to the system. So -1, -1 is a true point on both of those lines. So let's look at the next problem. So again, I'm going to do blue for the top one and green for the other one. So the blue equation is already in slope-intercept. So I can go ahead and sketch that line real quick. We have a y-intercept of 3, so I'm going to come down here to -3 is my y-intercept. My slope is +1 over +3, so that's telling me to go up 1 and right 3. So I'm going to go up 1, right 3 to my next point, up 1, right 3. I can also flip the signs of both of these numbers to give me a -1 over a -3. Again, those two negatives would have canceled, leaving you again with a positive, so I'm not changing it at all. I just want to look at it differently, because a -1 tells me to go down 1 and a -3 in the denominator tells me to go left 3 instead. So I'm going to go down 1 and left 3, and as you can see, I'm continuing this straight line. So I'm going to sketch this out. All right, so that was that one. So let's look at the next one. So the next one is in standard form. So that means I need to solve to get y by itself. And this one's going to go pretty quickly because y doesn't have anything being multiplied to it. I just have to go and subtract 2x on both sides. So doing that, I get y equals -2x plus 4. The 4 was positive, hence the plus 4. I want the -2 to be in front, because that is just the formatting. So on this one, I can see that I have a y-intercept of +4, so I'm going to go up to +4 on this. My slope is -2 over 1, so that's telling me to go down 2. and to go right 1. So from here I'm going to go down 2, right 1. Notice I'm going in the same direction as the line, so I'm going to keep on going. So I'm going to go down 2, right 1, down 2, right, ooh, I hit a point, perfect. Down 2, right 1, and I'm going to sketch that line. So you always know that for the most part, a lot of these problems, the points of your slope are going to hit at the same location. And that's what you want to hope for, because that is showing you that these are nice numbers. So even if you can't draw a straight line, you know it should have landed on that point. So looking at this point, let's see, we go 1, 2, 3 to the right. So my x value is 3. And then I had to go from there down 1, down 2. So negative 2 for my y. So I'm at the point 3, negative 2 for this intersection. And we can, of course, go and check. So my first equation was y equals 1/3 x minus 3. The second one is 2x plus y equals 4. So let's plug in that 3 and negative 2. So for the first problem, that's a negative 2 equals a 1/3 times, so I'm going to put my parentheses for this x, 3 minus 3. All right, so 1/3 times 3 is just going to give me a 1. 1 minus 3 gives me negative 2. So I get negative 2 equals negative 2. Well, that's a true statement, so that's good. So now let's check it on the second one. So we get 2 times 3 plus a negative 2 equals 4. So notice I'm putting the thing I'm substituting in parentheses. I didn't do it for my y's on each of these examples because they were all alone. There was nothing going to be added or multiplied to them. But on this case over here, since I was adding to a y and I had a negative 2 I was substituting in, I'm just going to put that in parentheses. That's telling me, hey, I'm adding a negative 2 here. So first we have 2 times 3, which gives me 6. And adding a negative 2 is the same as subtracting 2. So 6 minus 2 gives me 4, and 4 does indeed equal 4. So I know that the point 3, negative 2 worked for both, so that is my final answer. So I have one for you to try. You have y equals x plus 5 and y equals negative 2x minus 1. So try this one out. See how you do. So on this one, you would have gotten the point negative 2, 3. So again, you would have graphed both of those lines, and then you would have seen that they intersected at the point negative 2, 3. So I just listed the answer. I did not draw it, but you need to draw both of these lines in order to find that answer anytime you are asked to graph to solve.